Good morning, everyone. It's a real pleasure today to be here today with over 18 years of experience in data engineering field. I have seen the evolution of data systems in action. And today I'm excited to share how AI is revolutionizing the way we build the systems, the way we build the data pipelines, and the way we move the data from one place to another place. Think of it as a journey. Okay. I will take you through the evolution of the data engineering from early days of my moving like simple data with basic data cleansing with basic workflows to today's intelligent automated way of moving the data. Along the way, I'll share some stories of both challenges and breakthroughs and how we can mitigate those challenges with today's AI world. See, the current state of data engineering. Okay, let me start by sharing a little bit of my own journey. When I began my career, a data pipeline often means moving a few data files from one system to another system, maybe cleaning them and then running a basic report for leaders or product managers and various users if it is related to operational reports. Fast forward to today, the landscape has completely changed. The data we deal with is like massive, dynamic, like frequent, increasingly unstructured because of the way it evolved and from where it evolved. It's not enough to just move the data around anymore. We need a system that can not only handle this complexity, but evolve with it. Today's discussion will revolve around how AI is playing a pivotal role solving these problems. I'll walk you through how AI is reshaping the data pipelines, making them smarter, adaptable, and more efficient. What is a data pipeline? Before we dive into AI, let's take a step back and make sure we are all on the same page about what we're talking and what's basic data pipeline is. Picture a traditional data pipeline like a factory line, okay, or a pipeline where data coming from various sources, it's getting processed and then ending up in a warehouse or a dashboard for analysis or for a basic data set that can be done like deeper insights by data scientists or business intelligence engineers. Yes. But as data grows larger and more complex and more varied, this factory line needs to become like more sophisticated. Okay. The old systems are not like designed to handle this complexity. And that's where the challenge lies. The struggle is what we see in basically in these traditional pipelines are like, let me paint a picture of like early days. I remember like, let's say it was spending chasing down issues in the pipeline and debugging and finding the basic issues like, okay, data type not mismatching, like one field having a value which is not in line with like the way we design the schema and everything goes wrong. And it would take sometimes hours to debug and find and fix it. Maybe the data source might go offline or transformation step would fail just because of basic data type mismatch. And we were like literally scrambling to fix it. Those days were like full of firefighting. Okay, we're constantly pitching things up and then only to find new problems the next day. Okay, and scaling the system, updating the system to handle those problems. And that was kind of like headache. We would throw more hardware with the problem if it is like bottleneck from like efficiency. Maybe we build new custom scripts to try to make things faster or handle the mismatches in the data types. But even with all that effort, it was not sustainable. So we need something better. AI role in transforming data pipeline. Let's see, the turning point for me, like, okay, came when we started integrating, like looking into the AI, how we can leverage the AI. Suddenly the tasks that had like once taken hours, even days were happening like automatically. For example, okay, I'll take a hypothetical example here, manually checking your data quality. AI would flag anomalies in the real time. And the best part is like system was not just reacting, it's even learning from the pipelines, like why it's failing, how it's failing. Okay, what could be the potential issue? Like when we do some manual correction and then process and then give back that information to ML algorithm that's handling the pipelines, it's like a new learning for it. Imagine a system that learning on its own from the data and then getting smarter over the time. Obviously, this ML powered or AI powered data pipelines can automatically adapt to these fluctuations, adjusting the resources on the hardware side and improve their performance without like a very minimal human intervention. Key benefits when we include this ML and AI in the data engineering, some potential key benefits would be there, like impact of ML and AI is profound. We are not just improving the speed or accuracy, we're rethinking like how we can manage these huge data sets, huge pipelines with complex transit rules. For example, instead of worrying about like scaling up with like based upon the size and corresponding hardware requirements, resource requirements, Okay, just this algorithms like AI models will automatically adjust, adding like more resources as needed, and the best part is this happens like without human intervention. This addresses the need of like cost of hardware upgrades and manual interventions. And with cloud coming into the picture, this dynamicness like literally helps and allow us to focus on better tasks, like high level tasks and the business oriented things, rather than like spending a lot of time on the technical challenges on day-to-day basis. Real-time adoption, like obviously one of the most exciting aspects of AI is like real-time adaptability. Imagine during a flash sale, okay, all of a sudden like Black Friday or Boxing Day UK, okay, there is a sale going, and then the traffic spikes like unpredictably. In the past, we would worry like, okay, we can't predict like how much volume it could be, like, okay, how much hardware or resources we need to handle this. We would worry about like how systems would handle these new loads or often coming in. But with AI, the system can automatically scale and adjust itself, and it makes like decisions in real time, giving like business significant competitive advantage. It's like allowing like lightning fast adjustment for the ingestion, ensuring that there is no opportunities missed. Okay, there is no failure in the end-to-end execution, even in with like huge workloads and sudden spikes. Another beauty is like let me share one real world scenario. Let's see if there is like large financial institution had been studying to detect the fraud in the real time, and with the traditional systems, it's really difficult to handle it. The one reason is because it's not like a real time. With the AI that could analyze the transaction patterns in real time with the models that already being trained with enough data, and they detect these fraudulent behaviors and as it is happening, and before it could cause like much damage for the end user. It's like having a real-time security guard for your data. It's like having a real-time person there sitting for you and watching for you in terms of like what's happening around you, around your financial transactions. It's able to spot the anomalies and take action immediately, reducing the impacts and further any impacts. How we can optimize the efficiency in this AI-driven world? One of the most powerful features is AI-powered data pipelines in that are like not static. As I mentioned earlier, by analyzing the past performance data, that's these machine learning algorithms learn more, identify the potential bottlenecks, resource underutilizations, and inefficiencies, making proactive adjustments to the improved performance. For example, if a pipeline is running slower than usual, okay, the AI system can predict like what could be the future bottlenecks based upon what's happening now, or what's happened in the past, and suggest or implement resources adjustments before the impact performance or breaking down the things. End-to-end, how it works is, okay, imagine an end-to-end system where, okay, we have like data ingestion, data processing, storage, and final analysis or usage of this processed information. This AI dynamically selects the most relevant sources and formats only. Okay, and its advanced algorithms automatically clean, transform, and even enrich the data from like missing values or missing missing details in the upstream systems, or not entered by the users, or like issues in the legacy systems. But all these will be taken care through, while we doing the processing of the data or transforming the data. And finally, when storage also is automatically optimize the storage, okay, the best way of storage in terms of like the level of the aggregation we need. It would recommend like, okay, how to store, where to store, and level of the grain we need to maintain, and based upon the future access requirements. And in the end, like, okay, once we do all this, obviously we need this data for analytics and insights, and AI-driven analytics helps surface the most important insights, flagging like any issues or anomalies, and key patterns and deviations from like expected patterns of progress before anyone, like any human intervention comes into picture, or any analyst or business user look into the data itself. This is the future of data engineering. It's seamless, intelligent, and fully automated. Let's see a case study. Let's look at like a real world example. A real client faced delays in generating daily sales forecasts because of the slow data processing. Obviously, if someone need to take a decision before like 8 a.m., okay, and the pipeline's taking like much larger time, and we see a surprises in terms of failures, okay, it would be like massive disaster, obviously, because they can't take decision on time, and it's giving an edge to the competition if we don't have like information available on time. And by switching to this AI driven like pipeline management that could process data in real time, allowing them to generate daily forecasts in hours instead of days. Yeah, this will allow them to adjust the price strategies, managing the inventory requirements effectively, and even personalize the marketing efforts, all based upon like up to minute data. Like, okay, what's happened last minute would drive like what could happen in next minute, that kind of scenarios. This is the kind of transformation we are seeing in the industry, and AI is playing a real major role here and driving meaningful change in how companies should operate and will operate. What are the some key technologies driving these? Now let's take a look at the technologies that behind this powered AI powered pipelines and ML powered pipelines. One basic thing obviously is machine learning and the deep learning. These models, I mean, when learned from like past issues, adapt and improve based on the historical data, making the pipeline more smarter over the time, like making these end-to-end movement of data more smarter over the time. Say NLP is another thing like natural language processing. This allows pipeline to process the unstructured data more effectively, like text, logs, or even converting the audio to text and then process, and then massively unstructured data will be taken care of here. Another advantage here we can see is in terms of NLP, because it's like behaves like a human understanding the information and then processing. Okay, take some example like missing city based upon the postcode. Okay, anyone can say city name. It could be taken care. Similarly, name misspelled. Okay, say instead of my name Srinivas, instead of SRANIVAS, someone spelled like A is missing, and NLP have that ability to repopulate the correct value based upon what it learned in the past. This automates the selection and tuning of the machine models, like machine learning models for more optimal data transformation. And another one is like cloud infrastructure. Obviously, to have this dynamicness and necessary scalability in real time and the flexibility in real time, the infrastructure should support the way we leveraging the infrastructure to support all of this, and cloud is the main thing that's required, which is the foundation for all these things. Together, like all these technologies will enable that next generation of data engineering. How to get started with AI in data engineering? Okay. Step one, obviously, we need to assess the current infrastructure, current pipeline, identify all the pain points, list down everything in the backlog, and we can just check like, where we could apply these AI ML models to have like more impact. Obviously, we need to bring the return on investment into the picture before moving forward. But that's the step one. And then selecting the smart tools, the right tools, and the framework that best suit to have like these new effective and efficient data architecture and goals. And start small. Better to start like, implement a small solution, that driving through ML models, implement scale and iterate, like see like, is there any benefit happening and how much benefit it's happening? And then iterate and apply more models like on the pain points to improve the things. Once we scale up, like doing the scale up, we'll get like more confidence in the system. And we'll see the more benefit, like how these are helping in terms of like both business and also like technical team, and then expanding the scope across the data architecture. The key is here is to start small, manageable project that team can handle and build from there. What could be the future trends? One is like self-healing or self-handling pipelines. We can say, imagine a system that automatically detects and resolves some problems and then without any human input. That's like a North Star. It's not like a day-to thing. It could be like long-term long-term effort way to be there and still we're evolving. And real-time data processing. As of now, we have real-time processing working in a conventional way. But when we have like more advanced ML models, we will see like even faster processing in more use cases, enabling business to make instant decisions based upon that real-time data processing across systems, across areas. And then augmented engineering. Data engineers will eventually work alongside with the AI systems and ML models, using them like supporting tools to optimize the workflows and integrate them in the business processes for impact. We just started scratching the surface of what AI can do in the data engineering world. But I mean, it's not the final thing. Like we could see more advancements, we could see more surprises in future. And final conclusion, and what could be the next steps to wrap up? Okay, in terms of like AI is fundamentally transforming the way we processing the data engineering by making pipelines more smarter, more efficient, more adaptable. And we're seeing a shift from manual process to self-optimizing intelligent systems. My call here for action for all of us today is like, just embrace it. Embrace AI, use it. Whether you're just starting already experimenting with AI in your systems, take the next step, just integrating it with your data architecture. That is like a starting point, both in terms of learning and or both in terms of like seeing the benefits. Thanks for all. I mean, thank you very much for your time today. I'd be happy to answer the questions if you have any, or the comments or offline. Thanks a lot. Thank you very much.